Hello everyone. Let's dive straight into identifying bottlenecks in intelligent architectures. The formal definition of troubleshooting complex architectures is the systematic process of isolating, diagnosing, and resolving failures within a multi-layered system where Power Apps, Power Automate, and AI services interact. In plain everyday English, it is finding the kink in the garden hose. You see, when you have a long hose made of different pieces, one for the tap, one for the middle, and one for the sprayer, and water stops coming out, you don't just throw the whole hose away. You walk along the line, section by section, until you find where it's twisted. In our intelligent apps, the water is your data. Imagine you run a local library app. A user clicks borrow, but nothing happens. Is the button broken? Is the AI not reading the book title? Or is the database full? Stay with me here, because troubleshooting is about being a data detective. You've probably seen this at the office, where someone says the system is down, but really, it's just one tiny connection that came loose. Let's break this down together. We are learning how to spot the twist in our digital hose. So, now that we've mastered the idea that we need to isolate the problem area, you might be wondering how we can actually see the data moving through those pipes to find exactly where it stops. Well, that brings us right into our next step, which is using Power Automate Run History for debugging. This brings us to Power Automate Run History. The technical documentation describes Run History as a detailed log of every execution of a flow, providing the status of each individual action, the exact inputs sent, and the outputs received, including error codes and execution duration. To speak naturally, it is the digital autopsy. When a flow fails, we don't guess what happened. We open up the body of that specific run and look at the organs. Each step in your flow will have a green check mark or a red X. Imagine a dummy example. You have a flow that sends a happy birthday email to customers. You see a red X on the send email step. You click it and it says error 404, email address not found. Now you aren't guessing anymore. You know exactly which organ failed. You have probably noticed at the office how much time is saved when you can just look at a log instead of asking everyone, what did you click? Run history is your primary witness. Let's break this down together. We are looking at the evidence of what went wrong. So now that we've mastered how to read the digital autopsy of a failed flow, you might be wondering how we can check the pulse of the AI model specifically, especially when they give us an answer that is technically success but actually wrong. Well, that brings us right into our next step, which is monitoring AI builder performance and confidence scores. Now we need to talk about AI confidence scores and throttling. The formal definition says that AI troubleshooting involves evaluating the confidence score of a model's output and monitoring service limits or throttling to ensure the AI service isn't being overwhelmed by too many requests at once. In simple everyday English, it's checking the AI's self-confidence. Sometimes the AI succeeds in giving an answer, but it's a guess. Think of a dummy example. You have an AI that reads parking tickets. A user uploads a blurry photo. The AI reads the plate number as ABC123, but its confidence score is only 15%. If your app just accepts that, you've got a big problem. Troubleshooting here means looking at why the score is low. Maybe the light was bad or the camera was dirty. Stay with me here, because if you send 1000 photos in 1 second, Microsoft might throttle you, which is like the AI saying, slow down, I can't breathe. You've probably seen this when a website makes you wait for a minute because it's too busy. That is throttling. Let's break this down together. We are ensuring our AI is both confident and calm. So, now that we've mastered how to check the AI's confidence and pace, you might be wondering how we track down problems that happen right on the user screen before the data even reaches the AI. Well, that brings us right into our next step, which is Power Apps Monitor and client-side errors. This brings us to the Power Apps Monitor. The technical documentation defines Monitor as a tool that provides a log of all user activities within a Power App, capturing every function call, data request, and UI event to help identify performance lags or client-side crashes. In plain language, it is the hidden camera. It watches everything the user does and records the conversation between the phone and the server. Imagine a dummy example. A user says, the app is slow when I search for red shoes. You turn on the monitor and watch them do it. You see that when they type red, the app is accidentally asking the database for every shoe in the world instead of just the red ones. The monitor shows you that heavy lift in real time. You've probably noticed at the office how hard it is to fix a problem you can't see. The monitor gives you X-ray vision into the user's phone. Let's break this down together. We are catching the glitch in the act. So now that we've mastered how to watch the user's screen for hidden mistakes, you might be wondering how we handle those silent failures where everything looks fine, but the Dataverse filing cabinet is actually refusing to save the information. Well, that brings us right into our next step, which is Dataverse trace logs and plugin errors. Let's dive into Dataverse trace logging. The formal definition describes the use of the plugin tracelog to capture detailed telemetry and error messages generated by server-side logic such as plugins or calculated columns which may block data from being saved or updated. To put it very simply, it is the secret diary of the filing cabinet. Sometimes the front door of the app is fine, but the filing clerk in the basement, Dataverse, is having a breakdown. Imagine a dummy example. You are building a flight booking app. The user hits book, the app says success, but when you check the list, the seat is still empty. You check the trace log and see a secret message from Dataverse. Error: cannot book seat because the passport number column is missing a digit. The clerk rejected the file silently. Stay with me here because trace logs find the invisible number. You've probably noticed at the office how some things disappear into the system. Trace logs are how we find where they went. Let's break this down together. We are looking deep into the basement of our data. So, now that we've mastered how to find the secret errors hidden in the filing cabinet, you might be wondering how we take all these different clues and put them into a big picture dashboard so we can stop problems before they even happen. Well, that brings us right into our next step, which is using Azure Application Insights for global monitoring. Finally, we reach Azure Application Insights. This technical area focuses on the enterprise level integration where you connect your Power Apps and flows to an Azure Log Analytics workspace to track global health, user trends, and system failures across the entire company. In our relaxed classroom tone, it simply means the Mission Control Center. As a trainer with over 25 years in the industry, I have seen that the best troubleshooters are the ones who don't wait for a phone call to know there's a problem. They look at a big screen in Mission Control and see a red light flashing. They say, aha, 5% of users in London are having a slow experience with the AI. They fix it before the London office even opens. Imagine a dummy example. You are a doctor for the whole company's digital health. Application Insights is your heart monitor. Let's break this down together. As builders, we are the architects of reliability. We've looked at finding the kink in the hose, the digital autopsy of the run history, checking the AI's confidence, the hidden camera of the monitor, the secret diary of the filing cabinet, and finally, the Mission Control Center. We've mastered troubleshooting complex intelligent architectures. You now know how to keep your intelligent world running smooth even when the pressure is on. Well, that brings us right into our next chapter,